हेलो स्टूडेंट्स, हाउ आर you? कैसी तैयारी चल रही है? वेलकम टू माय यूट्यूब चैनल. Today I shall discuss more about Arrhenius equation. We have studied the Arrhenius equation. K is equal to rate constant. K is equal to a e की power minus e a upon RT. This equation is known as Arrhenius equation. Here K is rate constant. A is pre-exponential factor or frequency factor. A is activation energy of the reaction. T is absolute temperature. Here the factor e की power minus Ea upon RT represents the fraction of molecules whose energy is more than activation energy. This equation also shows that by increasing the temperature or decreasing the activation energy, the value of rate constant increases. Thus, the rate of reaction increases. It means that if we increase the temperature or if we decrease the value of activation energy, then the rate of reaction will increase. Reaction will become faster. Now, taking natural log of both sides of this equation, we have ln k is equal to natural log a minus Ea upon RT. If we take the natural log of both sides of Arrhenius equation, then we obtain ln k is equal to ln a minus Ea upon RT. This equation is equivalent to equation of a straight line y is equal to c plus mx. Now if we plot 1 upon t against natural log of rate constant k, then a straight line is obtained. Here at y-axis we have taken ln k and x-axis is 1 upon t. Here the slope will be equal to minus Ea upon r. Slope is equal to minus Ea upon r, and the intercept is equal to ln a, and the intercept is equal to ln a. Now by graphical representation, if we obtain the slope, then from the slope we can obtain the value of activation energy for a particular reaction. Since R is a constant whose value is 8.314 joule per Kelvin per mole. From the intercept of this straight line, we can also obtain the value of frequency factor or pre-exponential factor. So by graphical representation, we can also calculate activation energy by plotting 1 upon t against natural log of rate constant k for a particular reaction. Now, if at temperature T1 the value of rate constant is K1 for a particular reaction, then we have ln K1 is equal to ln A minus Ea upon RT1. A pre-exponential factor or frequency factor is a constant for a particular reaction. Now, if at temperature T2 the rate constant is K2, then we have ln K2 is equal to natural log A minus Ea upon RT2. This is equation number 1 and this is equation number 2. At temperature T2, the rate constant is K2, therefore we have ln K2 is equal to ln A minus Ea upon RT2. Now, from equation 1 and 2, on subtraction, we can obtain the equation ln K2 upon K1 is equal to Ea upon R within bracket 1 upon T1 minus 1 upon T2. If we convert natural log to the base 10, then we have log K2 upon K1 is equal to EA upon 2.303 or within bracket T1 T2 T2 minus T1. This is also a form of known as integrated form of Arrhenius equation. Log K2 upon K1 is equal to EA upon 2.303 or T2 minus T1 upon T1 into T2. By using this equation, we can calculate the activation energy EA for a given reaction if we know the value of rate constant K1 and K2 at the temperature T1 and T2 respectively. By using this equation, we can easily calculate the value of activation energy by knowing the values of rate constant at two different temperatures. Here R is a constant whose value is 8.314 joule per Kelvin per mole. This is very useful equation, Arrhenius equation in another form. We use this equation for solving many numerical problems. So today I have discussed about integrated form of Arrhenius equation and its graphical representation. How we can obtain a graphical representation of Arrhenius equation. We have obtained the graph between 1 upon T versus ln K. A straight line was obtained and the slope of this straight line was EA minus EA upon R and the intercept was ln A. By graphical representation, we can also calculate the value of activation energy for a given reaction from the slope. If we plot 1 upon T against natural log of rate constant, from the intercept, we can also obtain the pre-exponential factor. These are the two representation of Arrhenius equation in graphical form, and this is known as integrated form. This form will be helpful in solving different numericals in chemical kinetics. Thank you for watching my channel. You can suggest any other topic. Your feedback is required. Your comments are welcome. Thank you once again.